All right. Good day, dear listeners and viewers. We're happy to be back online, furthering in our lessons about blasting and acing our post-UTME examination. By the special grace of God today, we'll be extending our reach to solving problems. And before we start, it is better said that appreciation begets repetition. In this same vein, we want to appreciate everyone that has contributed to the success of our online presentation and teaching and learning. Ladies and gentlemen, we want to thank Chemistry International for their resounding efforts in line to making this come into fruition. We want to thank everyone, our counterparts in the University of Lagos, our counterparts in LASU, in University of Ibadan, Obafemi University, and a host of others. By the special grace of God, these questions, they are gotten from past questions, 2013 to be precise, the post-UTME questions of Obafemi University. So believe you me, we are going to be going in tandem with what we've promised to achieve. Chemistry is what we are going to be doing today. All right. This is a question, chemistry question, past question, 2013 to be precise. By the special grace of God, we want to solve these 5 questions and give you tips and insights in order to ace your examination. Question number 1. A motor truck releases an average of 5.0 gram CO, carbon monoxide, into air for every kilometer covered. How many molecules of carbon monoxide will be emitted into the air if the truck travels 8 kilometers? Solution. Number 1. What our objective is to calculate the number of molecules of carbon monoxide that will be emitted into air. Under questions like this, we have a series of equations to solve similar questions like this. And I'm going to give you 4 of them. M is equal to M all over molecular mass. Concentration times volume. Then we have number of particles divided by Avogadro's constant. And this is equal to volume all over molar volume. When you want to solve questions that are related to number of molecules, which by the virtue of the question, you can use either of these 4 formulae. Number of mole is mass over molecular mass. The same thing as concentration times volume. Believe you me, if the concentration is in molar, that is to say mole per dmq, the volume must be in dmq. That is why whenever the volume you are given is in cmq, you have to divide it by 1000. It's also equal to number of particles all over Avogadro constants. Avogadro constant, for you to know that, I believe you know that, is 6.02 times 10 raised to the power 23 per molecules. Do you understand? And this number of particles can be either of 3 things. These particles alone can be atoms, ions, and molecules. In abbreviation, I call this AIM, A-I-M. The particles can be atoms, ions, and molecules. Then we have volume over molar volume. The molar volume is usually 22.4 dmq. Now, if you look at this question properly, it's an applied question, and I don't want to bother much on that. It's one of the environmental chemistry aspects coming from environmental chemistry, and that is why many of chemists that were working in the environmental part of the chemistry, they must have a sound knowledge on what we call pollution. on what we call pollution. So this is pollution. Believe you me, there are so many vehicles on our road that must have been off-road by now. There are so much many vehicles on the road that they should have been off-road simply because the pollution that they release to the environment is much more unbearable. So we want to solve the problem. Look at the parameters that we are given. What we are in need of is how many molecules, number of molecules, which is the same thing as number of particles. I say particles, same thing as molecules of CO will be emitted into the, and we are given the mass of carbon monoxide. We are given the mass of carbon monoxide, we are given M. This is a value that we can easily, M, this capital letter M, like you all know, is molecular mass. It is also a constant. Definitely, we are given M, we can get capital letter M. We can get number of atomic particles, which is a constant, and we need the number of particles. Therefore, you are going to combine these two equations. We are going to say number of mole is mass over molar mass, same thing as number of particles divided by 6.02 times 10 raised to the power 23, which means this is the two equations we are going to combine together. From the question, the mass of the carbon monoxide M is 5.0 gram. The molecular mass of carbon monoxide, mass of carbon is 12, and the mass of oxygen is 16, that is 28 gram per mole. At this point, let me quickly raise an observation. The observation is that it is not every parameters that you are going to be given. Look at this, for instance, it was brought forth from my memory, which means you must know the atomic mass of each element. You must know the atomic mass of each element. Now let me give you the clue. From atomic number 1 to 20, if the atomic number is an even number, you just have to multiply the atomic number by 2 to get the mass number. If the atomic number is an odd number, you multiply the atomic number by 2 and you add 1 to get the mass number. For example, carbon, the atomic number is 6. It is an even number. So we are going to multiply it by 2 to get 12, which is the atomic mass. For example, oxygen is 8, atomic number 8. The mass number is multiplied by 2 to get the mass number. But for instance, if it were to be, sodium, atomic number 11, you multiply this by 2. Since it is an odd number, you must add 1. So that is 11 times 2 plus 1, that's 23. However, there's an exception to this rule. The exceptions include chlorine, hydrogen, and nitrogen. The atomic mass of hydrogen, the most abundant isotope is 1. Of course, we have 3 isotopes of hydrogen, the proton, the deuterium, and the tritium. But the most abundant one is atomic number, mass number 1. Of course, nitrogen, the atomic mass is 14. Even though the atomic number is 7, so if you are to get the mass number with the formula that I've just given you, it's going to be multiplied by 2 plus 1. But it is an exception that doesn't follow that formula. Therefore, the mass number is 14, 7 times 2. Chlorine as well, the mass number, the atomic number is 17, the mass number is 35.5. That is the relative abundance, depending on the relative abundance. So this is the molecular mass, 28 gram per mole. We've gotten this, we've gotten this. We need this, number of particles. Mathematically, if you solve this mathematically, number of particles, you are going to cross multiply. You are going to cross multiply. That means number of particles times molecular mass is equal to mass times 6.02 times 10 raised to the power 23. You are in need of number of particles, you divide both sides by molecular mass. That becomes number of particles times molecular mass divided by molecular mass is equal to mass times 6.02 times 10 raised to the power 23 divided by molecular mass. So this cancels out. Therefore, the number of particles is equal to the mass that we've gotten to be 5.0. The constant 6.02 times 10 raised to the power 23, and the relative molecular mass, which is what? Which is 28 gram per mole, which is 28 gram per mole. Do you understand?
Yes. Yes.
Which means we are going to get this calculation done. If you press it, that will be 5.0 times 6.02 times 10 raised to the power 23 all over 28. That gives us 1.075 times 10 raised to the power 23 times 10 raised to the power 23. Remember, number of particles. In this case, we are asked for the what? We are asked for the how many molecules, number of molecules. Therefore, the number of molecules is equal to 1.075 times 10 raised to the power 23. Believe you me, what they are talking about here is actually, they are talking about for every kilometer. We have just calculated for every kilometer. The question says, travels 8 kilometers. So into the air, if the truck travels 8 kilometers, what that means is that 1.075 times 10 raised to the power 23 for 1 kilometer. Then for 8 kilometers is x. You cross multiply, you make your x the subject of the formula. That would be 1.075 times 10 raised to the power 23 times 8. That will give us a total number of what? That gives us 8.6 times 10 raised to the power 23. So therefore, the automobile, the motor truck, will produce a sum total number of molecules of carbon monoxide of 8.6 times 10 raised to the power 23. 23 molecules will be produced in every 8 kilometers. So which means for somebody that is having problem with his breathing, because this carbon monoxide competes with the oxygen in our hemoglobin, and so therefore it will cause a lung problem. We'll have a lung disorder. As we are breathing, it will become much more difficult. So what that means is that for medical scientists, it therefore means that if this is produced into the air, there will be problem for such persons. What that means is that the number of particles that can be produced into air at any particular point in time should have a limit. So if it is exceeding that limit, then there is a problem. And that is the application, which means that if it is exceeding the limit for every kilometer, they should take that bus, that automobile off road. So that satisfies our question number 1. So we move on to question number 2. So that's the answer to question number 1. We move on to question number 2, which says a sample of an organic compound was weighed to 0.250 gram and subjected to Kejal treatments. Do you understand? Kejal is a scientist who discovered how we can quantitatively measure the composition of nitrogen in organic or inorganic compounds. Kejal is a method that involves digestion and a host of other procedure. But the objective of Kejal method is to measure quantitatively the amount of nitrogen in organic and inorganic compounds. So the question is, a sample of an organic compound was weighed to this mass and subjected to Kejal treatment. The ammonia produced was neutralized by this volume of 0.1 molar HCl. What is the percentage of nitrogen in the compound? Ladies and gentlemen, what we need is the mass of nitrogen all over the mass of the organic compound multiplied by 100. This is the way to know the percentage composition of nitrogen in the organic compound. Do you understand? However, we were not given the mass of nitrogen. We were not given the reacting mass of nitrogen. It therefore means we need to know the reacting mass of nitrogen. However, we were told that the ammonia was produced from the organic compound, and the ammonia was discovered to be neutralized by 27.0 cm cube of 0.100 molar HCl, which means there was a reaction between ammonia and HCl to give ammonium chloride. This HCl, we were told that the volume is what? The volume is 27.0 cm cube, and the concentration is what? 0.1 molar. We are not in need of this. This is what we actually need. Because if we know this, we can actually get the mass of nitrogen from this. Do you understand? Because if we know the mass of this, the reactive mass of this, we are just going to say the mass of nitrogen all over the mass of ammonia multiplied by the total mass of ammonia, reactive mass of ammonia. That will give us the reactive mass of nitrogen. Do you understand? But we don't know the mass of ammonia yet, which means there must be a relationship to get the mass of ammonia. From stoichiometry, you have seen that the mole ratio is 1 to 1, which means whatever the mass, the number of mole of this is, it will be equal to the number of mole of this. Like I have told you initially, the number of mole can be concentration times volume, which means the number of mole of HCl, the concentration of HCl is 0.1. The volume of HCl, 27.0. Because it is in cm cube, you have to divide it by what? By 1000 cm cube. If you do that properly, that is what? That is 0. That is what? 0.1 times 27